Okay, in previous one, we discussed that whenever we give the heat, so the temperature will increase of any of the object. And mostly we were talking about the increase in temperature by 1 degree centigrade or a specific change from this to this, that was going to be happen. But in today's topic, that is specific latent heat, we are going to discuss whenever the state of change will occur. For example, solid will become liquid or liquid will become solid like this. How this thing going to be happen? Definitely, whenever you want to change the state, you have to give some heat or you have to take out the heat from that one. Then this change is going to be happen. So the first thing we are going to discuss is about specific latent heat of fusion. Basically, what will happen in latent heat of fusion? Here you can look at this definition. First of all, Rehan, can you read this blue box?
Yes, sir. Sir, can you go to the blue box?
Now, can you see this?
Yes, sir. The specific latent heat of fusion of a substance is the quantity of the heat needed to change unit mass from solid to liquid without temperature change.
This one is very important point without temperature change. Basically, what will happen? Whenever you give the heat to any of the solid, you want to convert into liquid. Let's suppose if you have some amount of ice and you want to make it water, you start to give the heat to it. So what will happen when you start to give the heat? Sometime it will gain the heat and then after they will start to melt down. One interesting thing is what that you will continuously give the heat. Let's suppose if you put ice in one of the beaker and you give the heat, what will happen? They start to melt down. Very cold water will be observed inside of it and some piece of ice will also be there. You can take the temperature at this moment. The temperature will be what? Yes, Alisha. Can you tell me what will be the temperature of water at that time? Whenever it will going to melt from ice, what is the temperature of ice at that time whenever cold water is there?
Zero.
0 degree centigrade, right? And you will find very little amount of water there. Continue giving heat to this, and after that, you will see that half of the ice has been melted, but the temperature will remain zero. How long the temperature will remain zero, Rehan?
Sir, until the next change take place.
Yes, until the complete ice will melt into water. The temperature will not change. So we are continuously giving the heat. Whenever the first drop of ice was melt till the last drop of ice was melt and it is completely water, we give continuous heat. So what happened with this heat? This heat not able to change the temperature just like the yesterday one. All this heat consumed to change the state from solid to liquid there, right? What will happen in this case? All this heat will be consumed to change the state. This heat is called what? Specific latent heat of fusion. Understand? This heat is what? Which will change the state from solid to liquid without change of temperature. This total heat consumed, this total heat utilized to change the state. So this heat called specific latent heat of fusion. Understand this concept or not?
Yes, sir.
Yes, Alicia, understand?
Yes, sir.
Okay, note down this definition. Specific latent heat of fusion. It is mostly represented by LF, small l and a very short f at the subscript. It means latent heat of fusion. Yes, yes. Q is equal to M multiply LF. This Q is that heat which is required to change the state. And M means the mass of that object, 1 kg, 2 kg, half kg. And LF, latent heat of fusion of that specific ice or any solid. Note down this formula.
Yes, sir.
Writing. Yes, sir.
Okay, good. Now here, this one is the practical. I think that you will not going to perform this practical at lab. If I'll find the video, I will share with you. Here you will immerse that one and you will start to take that this water is this ice is going to melt in form of the water, and then you take the temperature of that one. You check that what will be the temperature of it, and you will find that the temperature will remain 100, right? And uh, here is the fixed value of latent heat diffusion 340 joule per gram. We will perform that one with some experiment. Second thing is about specific latent heat of vaporization. Okay, read from here. Rehan, this time you.
Yes, sir. A specific latent heat of vaporization. Latent heat is also needed to change a liquid into a vapor. The reading of a thermometer placed in the water that is boiling remains constant at 100 degrees Celsius, even though heat called latent heat of vaporization is still being absorbed by the water from whatever is heating it. When steam condenses to form water, latent heat is given out.
Yes. So first I explain, after that you can write. Here, let's suppose that if you are going to boil the water in a kettle, this one is the electric kettle which is used to make tea mostly. In this one, you put some of the water and then you start to boil the water. You can put a thermometer there. You can see the temperature of water is going to be increased 40, 50, 60, 70, 80, 90, 100 degrees centigrade. After 100 degrees centigrade, the temperature of water will not increase. What will happen after that? You will find that these type of vapors, you can see these vapors. I am unable to write over there because this one is open in Foxit Phantom. So you can see these vapors coming out from the kettle. These vapors will come out. It means the water is going to be changed in form of the vapors. Okay. And continuously the heat is going to be given. What will be the temperature of water at that moment if you put the thermometer in the water, boiling water?
Say 100.
100 degrees centigrade. And you are continuously giving heat to him, but you will observe that the temperature is not going to change. The temperature is not going to increase. It is remain at 100 degrees centigrade. And you will find that the vapors are coming out, and all the water is going to be vaporized. But one condition, water must be pure. If it is impure, then the temperature may be fluctuate. 100 degrees centigrade is the boiling point of pure water. Okay. So the temperature of water will not become 101 ever. It remain 100. Even that you will give as much heat from the electric oven, from the kettle, from the stove, it will not increase. After the 100 degrees centigrade, they start to change its shapes from liquid to vapors. All the waters will become vaporized and the temperature will remain. At last, you will find that what is the temperature of remaining water? It will remain 100 degrees centigrade. It will not increase. So that amount of heat which start to convert this water into vapor, this is called what? This amount of heat is called what? Yes, Alisha.
What, sir? The heat is for
What this one called? This amount of heat called
specific latent heat of vaporization.
vaporization. Yes. So this is that amount of heat which is used to convert water into vapors. Now note down this definition of specific latent heat. For this one, we write L of V. V means vaporization, L means latent heat, small l. And the formula of heat is same. Q is equal to M times L of V. Note down these two blue box. Okay, I. Okay, in this one, the fusion, according to the kinetic theory, whenever we give the heat, so this heat will use to increase the potential energy. of that molecules. And when the potential energy is going to be increased, whenever the energy increase, either potential or kinetic, their intermolecular force by which they both are connected with each other, they stop to break. They are going to break and they are not to be strong enough. So whenever they are going to be break, they are becoming free gradually. And when they free, they start to move away with each other. That's why in case of fusion, the solid will become liquid. Why? Because of the weakness of their forces. And how this weakness of forces will be happen? Because of the increase in potential energy. Okay. So what the key point? When you give the heat, the potential energy will be increased there. And because of the increase of this potential energy, their intermolecular force will become weak and the temperature will not increase, but their shape will start to change from solid to liquid. No need to write this one because this one is just the conceptual one. They mostly not ask about to write about it. Vaporization. Yes, Rehan.
Yes, sir. Vaporization, if liquid molecules are to overcome the forces holding them together and gain the freedom to move around independently as gas molecules, they need a large amount of energy. They will receive this as latent heat of vaporization, which latent heat of vaporization, which like latent heat of fusion, increases the potential energy of the molecules, but not their kinetic energy. Also gives molecules it also gives the molecules energy required to push back the surrounding atmosphere in the large expansion that occurs while a liquid vaporizes. To change 1
Okay.
kg of
Till
water
here it's
at
okay. In the vaporization, what will happen whenever you will give the heat? This heat again will increase the potential energy of the particle. Let's suppose the molecules of the liquid whenever you will give the heat, and they will be able to break their intermolecular force in between. So the molecules which were already loose because of the heat from solid to liquid, they will gain more heat and they will break. The force will break there, not the molecule. The force, intermolecular force, will break, and every molecule will become free. When they become free, they start to fly and escape from the surface of the liquid, and we call it that this one is going to change in the gas state from the liquid one. So this one is going to be happen because of the breaking of intermolecular force, and this breaking of intermolecular force occur because of the potential energy, because potential energy break them. Okay, for the vaporization. Now what is the difference between evaporation and boiling? First read and then after I will explain this one. Yes, Alicia.
Two energetic molecules close to the surface of a liquid.
Here two processes are there in which the liquid is going to be in case state of gas. These processes are evaporation and boiling. Evaporation is what? Evaporation is the process in which the particles convert, the liquid particles convert into the gas particles at every temperature. There is no need that you will provide special heat. Even that, if you will put some water in a plate in a AC room, it is not the hot room, because in the hot, you know that evaporation is going to be very fast. In AC room, you will find that after some day, the water, the amount of water will become reduced continuously, and then you will find that one day this plate will be
Yes, sir.
empty. Abdullah, welcome. Join late. Where you were, dear?
Uh,
Sleeping?
my father cut the Wi-Fi because of my sister, so I didn't even receive the message.
Okay. Why he cut the Wi-Fi?
He wasn't doing work.
Okay. Now we are going to discuss evaporation and boiling. I will provide the video to you so you can check that one as well and you can discuss with me. In this one, what's the thing? That evaporation is going to be happen at all temperature, even that the temperature is higher or the lesser. The evaporation process is going to be happen. But boiling process is what? Boiling process is the thing in which you provide the external heat. Then this liquid is converted into solid. So these two are the different processes but having the same thing, liquid converted into gas. What is the different thing? First, for the evaporation, whenever more temperature, it will more evaporate, right? Whenever you have a large surface area, the evaporation will be more. The third point, wind or drought. So whenever you have wind or drought, then you will find more evaporation there. What about the boiling? He didn't give the point about the boiling, because boiling is the process in which the liquid will become gas at a specific temperature, not at all temperature. Remember that evaporation is going to be happen at all temperature, but boiling is going to be happen at a specific temperature for every liquid, right? Every liquid had a specific boiling point. So these two are the basic difference of evaporation and boiling. First of all, note down the definition of evaporation, where I mark with this red sign, and factor, you can just write the yellow highlighted factor from there. Note down the definition, a few energetic molecules from here. Okay, after discussing this thing that evaporation is the process which will happen at all temperature, it depend on the temperature, it depend on the surface area, it depend on the wind. If these three are higher, then the evaporation will be more. The second thing is boiling. What is the boiling? Abdullah, read from here. Boiling.
Boiling. For a pure liquid, boiling occurs at a definite temperature called its boiling point and is accompanied by bubbles that form within the liquid containing the gaseous or vapor forms of the particular substance. Latent heat is needed in both evaporation and boiling and is stored in the vapor, from which it is released when the vapor is cooled or compressed and changed to liquid again.
Okay, thank you. In this one, he says that whenever any of the pure liquid you have, every pure liquid having a specific boiling point. As I told you, whenever you have a pure water, the boiling point of pure water is 100 degrees centigrade. And if you find that the temperature boiling point of the water is not 100 degrees centigrade, it is more or less, it means this water is not pure. Similarly, all the liquids having specific boiling point, they will not boil before reaching at this temperature, but evaporation is going to be happen at that temperature as well. And latent heat is required for both of these process, because this heat will store in the vapors. Let's suppose if we are going to vaporize, so this heat is stored in the vapors. Then when these vapors will become colder, they will again become liquid. Have you observed this phenomena that vapors convert into liquid? Yes, students. Whenever
No, sir.
any side the water is going to be boiled, vapors are coming, just put the hand over it, not so close, it can be harmful, but over of it. So what will happen when the vapors will come and strike with your hand? After some time, you will find that there is a water at your hand. How this water come? Because the vapors come, strike with your hand, and their temperature will become cool down. That's why they will again convert from vapors to liquid on your hand. Okay, same thing is going to be happen whenever your mother is cooking some of the food. You can see that the lid she put over the that sort of pot or dekchi. When you pick it up, you will find that there is a water over there. What will happen? The water vapors coming out from the food, they will strike with the upper part, the lid of that pot. They will become colder and they will become the water over there as well. So wherever you will find safely, observe that vapors are coming and you bring the hand over there, you will find the water there. Okay. Understand the concept of boiling?
Okay, sir. Yes, sir.
Now, the next thing I'm going to start with restarting the class because only 1 minute left in the 40 minutes. So reconnect the class. Okay. I'm sharing the link.
Okay.